Question 10 is an estimate the mean question, and it finishes off with some cumulative frequency. So the table shows some information about the weights in grams of 60 eggs. Calculate an estimate for the mean weight of an egg. Now anytime you're asked for the estimate for the mean, that is the one where you're going to need to find the midpoint and then an FX column. So the midpoint is you take your boundaries, so in this one it's 0 to 30, and you find what is the middle value. And once you found the middle value, you're going to assume that every egg that falls in this group, we are going to assume is 15 grams, or whatever the midpoint is. Now, finding the midpoint can be tricky with some numbers. In this case, it's 0 and 30, so we know that the midpoint is going to be 15. However, a method for finding the midpoint, if you can't work it out because they're slightly tricky numbers, is to take the low, add it to the high, and then divide by 2. So in this case, 0 plus 30 is 30, divide by 2 is 15. So here we've got 30 add 50 is 80, divide by 2 is 40. 50 add 60 is 110, divided by 2 is 55. And this ends up being 65, that is 85. Now, in order to find the FX column, I multiply my frequency by my midpoint. So 0 times 15 is 0. 40 times 14 is 560. 55 times 16 is 880. 65 times 21 is 1365. And 85 times 9 is 765. Now, in order to find an estimate for the mean, I need to take my total fx divided by the total frequency. So that's the total of this column divided by the total of this column. Now when I add those up, I get 60. However, I also know that they've told me in the question that they're looking at 60 eggs. So there's 60 eggs altogether. When I add this column up, I end up with 3,570. So to calculate the mean, I do 3,570 divided by 60, and that equals 59.5. And what we're working with here is grams, and that is saying that the average weight, based on the mean, the average weight of an egg is 59.5 grams. Part B is cumulative frequency question, and they're asking you first of all to complete the cumulative frequency table. Now, cumulative means to collect or gather as you go along. So if you notice, the difference between a cumulative frequency table and an group data table is that here our weight goes from 0 to 30, 30 to 50, 50 to 60, 60 to 70. But on a cumulative frequency, they always go from 0, so it's 0 to 30, 0 to 50, 0 to 60, 0 to 70. So this is when you need to add the values from the previous table. So 0 to 30, there's none. From 0 to 50, it's all of these eggs and these eggs. So 0 plus 14 is 14. Next, I'm looking for 0 to 60. So it's all of these eggs. So I add that 16 on, which is going to give me 30. Then I add on the 21, which gives me 51. Then I add on the 9, which gives me 60. And I can check again, my total frequency is coming out at 60, and in the question they told me that they were looking at 60 eggs. So there's my cumulative frequency table complete. Now, the next part of the question asks me, on the grid, draw a cumulative frequency graph for your table. Now, a cumulative frequency graph is usually going to look like that. I always think of it as a swan's neck. Some people think of it as an S, but it's always going to be that. And it's going to be a curve. Now, there are some things you need to realise when you're plotting a cumulative frequency graph, because, as the table suggests, we're looking at the uppermost values for each category. We are interested in the 30, the 50, the 60, the 70 and the 100. So that is what I plot when I'm plotting my cumulative frequency graph. So the first point that I want to plot has got a weight of 30 and a cumulative frequency of 0. So weight of 30, cumulative frequency of 0. Always plot with a cross. Now this is going to be on 50, so it's got a weight of 50 and a cumulative frequency of 14. So there's a weight of 50, there's 10, 15, there's 14. Remember to check the scale of your graph. The next one has got a weight of 60 and it goes up to 30. So 60 to 30. The next one is 70 to 51, 70 to 51, and the final one is 80, no it's not, it's 100 to 60. So there's 100 and I'm going up to 60. So what I need to do then, if I can zoom out, I need to join my points with a curve. It might be difficult for me to do at the angle that my hand is in, so it's best to do it in one smooth motion. And remember how the shape of a cumulative frequency graph needs to look. And it's going to end up as something like that. So not too far off what I predicted it would look like. They all look the same pretty much. So there's my cumulative frequency graph. Now, part D has asked me to use the graph to find an estimate for the number of eggs with a weight greater than 63. Now the fact it's asking me to estimate again means in this case that you've got to use your graph. So make sure that you are showing the examiner that you're using the graph. So I'm going to use my graph to find an estimate for the number of eggs with a weight greater than 63 grams. A lot of people get confused in this question. It's worth 2 marks and they think it's a little more straightforward than it actually is. So 63 grams. And I'm looking for a number of eggs with a weight greater than this. First thing I need to do is identify where 63 grams is on my chart. So there's 63. And I've got to use the graph. So I've got to draw my line up to the graph and then bounce it across. And that gives me a value of 38. Now, 38 isn't the answer to this question. There are 38 eggs below 63 grams. Because this is cumulative frequency, the 63 counts for everything below the little section we've drawn in. We want to know everything in the section above that we've drawn in. So we know that there were 60 eggs altogether. We also know that we are not interested in the 38 eggs that are less than 63 grams. That leaves me with 60 take away 38, which is 22. So the answer is 22 eggs. And the mark scheme would accept anything there between 21 up to 25. With regards to mark allocations, an estimate the mean question is always quite generous on marks, so it was worth 4 marks. Now the first of those marks you get for this column here, a method mark, and that's for finding at least 4 products, and remember a product means the result of a multiplication, so finding 4 products for fx that are consistent with the interval that you've used. The second mark is for using and finding the accurate midpoints. The third mark is a method mark, and you get that for showing that you've divided the 3,570 by the 60. Now you can use whatever number there that you have got as your total. So if you've got the wrong number there, you can follow that mark through and divide it by 60, and so that's actually your M1 mark. This over here then is your answer mark. So there's 4 marks for that question. Part B is a 1 marker, and you actually get 1 mark for getting all 4 correct. Part C was worth 2 marks, and in this case you get an M1 if you've got 4 of the points plotted accurately. You get an M1, and you get an A1 for a fully correct graph. So there's your 2 marks for that. Now for part D, again the mark scheme is quite generous. You get 2 marks for getting an answer within the range of 21 to 25. So that's 2 marks. Now, if you do not get your answer in that range, you can get 1 mark if you have shown this answer here. So like I said, a lot of people will just put 38 down and take that to be their answer. You would get 1 mark for that, so they wouldn't completely mark you wrong. Now, if you did neither of those because you've drawn your graph wrong, you can get 1 mark for showing that you've used the 63 weight, and then you can get your follow through answer mark for taking whatever value works with your graph. So that's a pretty generous 9 mark question. Question 11 is your standard probability tree question. Martin and Luke are students in the same maths class. This is Martin, this is Luke. The probability that Martin will bring a calculator to a lesson is 0.8. The probability that Luke will bring a calculator is 0.6. Complete the probability tree diagram. So let's deal with Martin first. The probability of him bringing a calculator is 0.8. Now probabilities always have to add up for 1. That means the probability of him not bringing a calculator is 0.2. So that's Martin done. Let's look at Luke. Luke's probability of bringing a calculator is 0.6. So the probability of Luke not bringing a calculator is 0.4, because they go together to make 1. And because nothing's changed here and he's unaffected by whether or not Martin brings his, this is going to be 0.6 for a calculator and 0.4 for no calculator. So there's Martin's probabilities, there's Luke's. That's 2 marks there. And the marks are for 1 mark, a B1 mark, for getting Martin right. And then you get another B1 mark for getting Luke right. Now part B wants us to work out the probability that both, and they've even put it in bold, that both Martin and Luke will not bring a calculator to the lesson. So I am looking for the probability of Martin not bringing a calculator and Luke not bringing a calculator. So I can think about this as a little story with regards to what Martin and Luke are up to and the path that they take through our story, which is the probability tree. So let's deal with Martin first, because we've got him. The probability of Martin not bringing a calculator is this root here, and that is equal to 0.2. Then I need to turn my attention to Luke, and the probability of him not bringing a calculator is 0.4. Now with probability, the fact that I'm looking at an AND means I multiply. If I was looking at an OR, I would have to add, But because I'm looking at an and it means going across the table, I have to multiply. And 0.2 times 0.4 equals 0.08. Again, this is a calculator paper. Don't take risks of doing these calculations in your head when you've got a calculator. Don't be a Martin and don't be a Luke. Don't not bring a calculator, right? Do what Martin and Luke do. 0.8 and 0.6. They bring a calculator. Make sure that's you. Anyway, looking at the mark scheme for part B, we get 1 mark for multiplying the values that you followed through from the table. So even if you've got the table wrong, you can still get that 1 mark, and then you get an answer mark for having the actual probability correct. Question 12 is a stratified sampling question. 182 students go to an outdoor activity centre for a day. Each student chooses one activity, climbing or sailing. The table shows the information about the activities the students choose: climbing, sailing, males, females. So just like a question back at the front of the paper, they've set this up in a two-way table for us to view easily. So the manager of the centre gives a questionnaire to some of the students. He takes a sample of 50 students, stratified by gender and by the activity chosen. Now, stratified means that you take a sample and you give special regard to what the variables are, in this case male or female, and climbing or sailing. So you need to look at very specific groups for a stratified sample to make sure everything's representative. So we need to work out the number of male students, so that's males, who chose climbing. So we've got a sample size. I'm going to write some key information here. Sample size of 50. I'm interested in males, and I'm interested in males that do climbing. So here are the males that do climbing. There's 34 of them. Now that is 34 out of our total number of students, which is 182. So 34 out of 182 are males that choose climbing. Now that gives me the proportion of people, or well, of males that choose climbing. So I want that proportion of my sample, which is 50. So I can go ahead and put that into my calculator as 34 divided by 182 equals, then times by 50, and that gives me an answer of 9.34. Do not make the mistake of leaving it as 9.34. We are dealing with the number of people here. You can't have 0.34 of a person because that would be very messy. So the fact that it's 0.34 gets rounded to 9. And that is a 2-mark question. You get 1 mark for showing the selected sample divided by the total times by the sample size, and you get the 2nd mark for getting the correct answer. Question 13 is a compound interest question, and it's only worth 2 marks. Once you know it, but it is something that you're going to have to learn and you're going to have to practice in order to remember. So Aminata invested £2,500 for N years in a savings account. She was paid 3% per annum compound interest. At the end of N years, Aminata has £2,813.77 in the savings account. Work out the value of N. Now remember, the value of N is the number of years. Okay, so that's what N actually represents. Now, compound interest, one of the first things I'm going to say about it is you can set it up as a formula with the amount of money. So amount of money times by the interest rate raised to the power of the number of years. Now that doesn't make an awful lot of sense in that form. I'm just telling you that's the format it's always in. Now in order to find the interest rate that we're going to end up multiplying by, we can see that the question mentions 3%. Do not be tempted to use 3%. We are talking about interest here. So she already had in her account 100% of her money. She is then getting an extra 3% from her bank. So her interest is actually 103%. That's how much she's got in the account at the end of her first year. And that's what is going to be put onto her account at the end of every year following that. Now, calculators don't like percentages, so I need to convert that to a decimal, either by dividing by 100, or a shortcut is that I know 100% is 1 whole. I know that 3% is 0.03. I can add them together and that's 1.03. So that's my multiplying factor. Okay, so Aminata invested £2,500 at an interest rate of 1.03 for n number of years. So there's that formula which didn't make any sense. That's what it's going to look like. Now they want us to work out the value of n. There's two ways of doing this. I can either solve it by putting the equation or the formula equal to the fact that I want to know £2,813.77. I want to know how long that took to get that amount of money. If I was doing it that way, I could divide by the 2,500 and then work out n from there. However, I'm going to do it sort of the methodical way, even though it's a little longer, because I think it's easier to follow. So I'm going to use a trial and improvement format. I'm going to say, first of all, if I know that that is what I need to get to, and that is what, that's what she needs to get to, that's the starting amount. I'm going to see, after 1 year, so n equals 1, how much money would I have? So I put in my calculator 2,500 times by 1.03 to the power of 1. So let's set that up on the calculator. I've got 2,500 times by 1.03 raised to the power of, so that's the x with the empty box, raised to the power of 1. And I'll press equals, and that gives me 2,575. So that equals £2,575. Is that what I wanted? No, it's not. It's way too small. I wanted 2,800. So I'm going to try the second year. So at the end of 2 years, I do not need to type anything back into my calculator. I left that there, and I'm going to press the back button until the cursor is up by that little 1, because I'm going to press then the delete button, and that little 1 goes, and I'm going to replace it with a 2 equals. So at the end of 2 years, she's got that amount of money. So when n is 2, she's got £2,652.25. Is that what she wanted? No, we're still quite far off. I'm now going to try when n equals 3. Back to my calculator. I'm just going to press the back button, delete that 2, put a 3 in its place, press equals. It's given me 2,731. Now there's quite a lot of decimals after this. Got to remember I'm dealing with money, so I wanted 2 decimal places. £2,731, and it wouldn't be 81 pence because the 7 would round the 1 up to 82 pence. Now that's pretty close to the amount, but it's not what I want, so I'm going to try a higher number of years. So let's see after 4 years. Back to my calculator, press the back button, delete the 3, replace it with a 4, equals £2,813.77. Of course there are the decimals, but we'd round it to 2 decimal places. And yep, that's exactly the amount of money I wanted. So that equals £2,813.77. That's what I wanted. So N equals 4. Now that feels like it was an awful lot of work just to get 2 marks, but remember I said that I went a really quite an inefficient method of doing that, but it is the most, I don't want to say common sense because it's definitely not common sense, but it's the most logical way to go about it. It's by no means the most efficient, but we got there in the end, and the mark scheme acknowledges that. So you get 1 mark for an attempt to evaluate that formula for at least one value of n that isn't equal to 1. So because I've trialled a number, I get 1 mark just for trialling. I then of course get an answer mark for correctly identifying 4 years. So that question was definitely worth a go. And finally, question 14. Question 14 is a histogram question, and I love a histogram question. I don't know why. I generally quite like questions involving graphs, but people seem to have a real dislike for histograms, and that's probably why I like them. So let's zoom in here. The incomplete frequency table, so the frequency table is this part. The incomplete frequency table and histogram, so that's that part, give some information about the heights in centimetres of some tomato plants. So these are all about tomato plants. Part A asks us to use the information in the histogram to complete the table, and Part B asks us to use the information in the table to complete the histogram. Now, I like to use the histogram and the table together in a sort of team effort to find out what's going on. Now, the first thing I always do when I've got a histogram and a table, if I zoom out, is I need to look for the key piece of information that helps me unlock the scale of my histogram, because I need a scale that goes up here for my frequency density, and I do not have one. Now, I have bars of specific heights, but that bar is for the heights 0 to 10. And 0 to 10 doesn't give me any frequency information, so that's no use to me. The 10 to 25 gives me the information in the table, doesn't give me the bar. 25 to 30 gives me the bar, doesn't give me the information in the table. 30 to 50 is in the table, it's not in the histogram. 50 to 60 is in the histogram, and yes, it's in the table. So that's my key piece of information there. Now, a histogram works exactly like area. So frequency of the bar, which is just a rectangle, is exactly the same as it would be if we were looking at the area of the rectangle. So this rectangle, which has a frequency of 20, I can consider that to be an area of 20. Now, how do you find the area of a rectangle? Well, it's base times height, or width times height. So I'm going to see that the width of my rectangle goes from 50 to 60, so it's got a width of 10, and width times height gives me the area. So I need to say that 10 times what will give me 20. Now, because they're quite easy numbers, I know that it's 10 times 2 gives me 20. So I know that this bar has got a height of 2. Now, on my axis, I can make a note that this line here is 2. I then look at the rest of my axes and try and work out a scale, and they've been very nice here because they're saying that each one big section of squares is worth 1. So my frequency density can go up to 4. Now, I used reasoning to find out the scale of this graph. However, there is a method to do it. You do not need to use reasoning. And it is all about area and widths. So the first thing I'm going to do on my table is I'm just going to put a little column in here for width. And that's going to just give me the width of the bar. So this goes from 0 to 10. It's got a width of 10. This goes from 10 to 25. It's got a width of 15. This goes from 25 to 30. It's got a width of 5. This goes from 30 to 50. It's got a width of 20. That goes from 50 to 60. So that's got a width of 10. So now I need to find out what the frequency is, and I also need to find out what the frequency density is, because frequency density is my height. So for the first one, I've actually got the bar there, and I can see that that's got a height. If this here is 1, then the height of this is 0.5. So I'm going to put that information in my table. It's got a height of 0.5. Now, area is equal to, let me zoom in a bit. Area is equal to width times height. So 10 times 0.5 is 5. So that bar has got a frequency or area of 5. Now for this one, I need to draw the bar in, so I need to find the frequency density. Now it's got a width of 15 and it's got a frequency or area of 30. So in order to find the frequency density or height, I need to take my 30 divided by my 15, because area divided by width equals height, and 30 divided by 15 is 2. So I know this bar has got a height of 2. So I can go ahead and draw that in. The bar goes from 10 to 25. So it goes in that gap. And it goes up to 2. So it's going to go up to there. I can draw it in with a ruler. Now I've made a silly mistake there, and I've made the bar too narrow. So I'm going to take it all the way across this time, and I'm going to shade that in. So that's that bar. If I do make a mistake like this, obviously I'll be drawing in pencil, so I can just rub that out. Do not draw a graph in pen, because if this happens, then you're going to have a messy looking graph and you're in trouble. So I've done that one. The next one, the bar is there from 25 to 30. It's got a height of 3. So I'm going to put that in my table. It's got a height of 3. So it's got a width of 5, a height of 3. That means its area is 15. Now I've got to draw my next bar in. It's got a width of 20 and an area of 50. So I need to do 50 divided by 20 equals, and if it was 50 divided by 2, it would be 25, but because we're dividing it by 20, it's going to end up being 2.5. So I've got to do a height of 2.5, and it goes from 30 to 50, and that's where 2.5 is. So I'm going to draw that in. So that's where that bar is going to be, and that's all the information. So I've drawn my 2 bars in. Okay, let me just shade that in so you can see it on the camera. There are my 2 bars, and there's a complete table. It's a 4-mark question. You get 1 mark for that, 1 mark for finding that, and then you get 1 mark for each correct bar. And there's your 4 marks, and we're done.